Page 670, lesson 11.2 is on multiplying and dividing rational expressions. So if you look at problem 1, they're asking what the product is and state any excluded values. So if you look at this, what we're going to do, we're just going to multiply those together. If you multiply those, you get negative 12 over a to the 5th power. And then basically excluded values would be something that would make the denominator equal to 0. So our denominator can't equal to 0. So a to the 5th can't equal 0. Well, a to the 5th is just a bunch of a's multiplied together. So if they're all the same and we multiply them together and we get 0, the only way that could happen is if they were all 0. So basically a cannot equal 0. To solve that, you could take the 5th root of a to the 5th, and then basically what times itself 5 times equals 0, and that would have to be 0. So there's our excluded value, a cannot equal 0. Part B, same idea. Before I even got started on part B, I would be putting parentheses around these binomials. So that's going to look more familiar to you of what you're going to need to do. And actually, temptation might be to go ahead and FOIL that out in the numerator. We actually don't have to do that. It's actually considered possibly more simplified if we keep it factored. Also, that will allow us to look for common factors with the numerator and denominator. So basically, it's just multiplying those, and then the excluded values would be if x equals 0 or if x equals negative 3. So these are not very exciting problems. We'll have more exciting problems later, I think. No canceling or anything right now with those, and that's probably what will happen with these at the bottom of the page as well. So let's look at the got it one. What is the product? State any excluded values. So same thing they just did. So that would be 15 over y to the 4th. And then excluded value, we don't want our denominator to equal 0, so if you wanted to, you could take the 4th root. Technically, anytime you take an even root, like we've talked about it with square root, 4th root would be the same. Technically, you put plus or minus in front of it because you would have an even number of factors, and so if you have an even number of negative factors, multiply those could make it positive. Anyway, in this case, plus or minus 0, it's all the same. Just y cannot equal 0. So look at part B. Again, if you want to put parentheses around your binomials to start with, and there's really not much happening on this one. We're just going to basically combine this into one fraction. So then excluded values, each of the factors in the denominator can't equal 0. If either one of those was equal to 0, you'd have 0 times something, which would be 0. So if you work that out, x can't equal 2 and x can't equal 3. Those are our excluded values, and then this would be our product. Kind of an interesting turn of events here. If you look at this at the top of the next page here, it says, as problem 1 indicates, products of rational expressions may have excluded values. And then it says, for the rest of this chapter, it is not necessary to state excluded values unless you are asked. I'm not sure why they're changing their tone all of a sudden, but anyway, I guess that's what we'll do then. And then now, more exciting problems here coming. If you look at problem 2, it talks about how we might have to divide out common factors. So on problem 2, if you look at that, in the numerator, there really wasn't anything they could do in the numerator. If you wanted to combine that into one fraction, you could. In the denominator, if you'll notice with the 7x minus 21, that has a 7 that you could factor out. Would be 7 times quantity x minus 3. And this other denominator, we can factor that into two binomials, x plus 5, x minus 2. Okay, and again, anytime I've got a binomial, I'm going to be putting parentheses around it, that force field that does not allow me to cancel it unless I see something that's identical. I do see something identical here, though, is that we have x plus 5 factors both in the numerator and denominator. We can cancel. Also, the 7 and the 14 we can reduce by 7. And again, the book kept it as two fractions. I would probably just throw it all together as one fraction and then reduce, and then that would be our answer. And they didn't ask anything with excluded values, so then I guess we will not worry about that for that problem. So if you look at the got it 2a, they're wanting us to figure out this product. So again, I would start by putting that binomial in parentheses. If you want to put the trinomial in parentheses, you can. Basically, just make sure you don't cancel any of those things out. So one thing you might notice here in the second fraction, we have a trinomial. And if you look at the denominator, I'm going to go ahead and put this x in front. I like monomials before binomials. And then see how in the denominator we have an x plus 2 factor. There's a good chance we're going to have an x plus 2 factor in the numerator as well to make this an exciting problem for us. And then that would be x plus 2 times x plus 1. When we get to that point, then they're not asking us for excluded values, so we can go ahead and start canceling if we see anything. X plus 2's can cancel. And then also we could reduce by an x. We have an x squared and an x, so we can reduce those both by x. And if you'll notice, our denominator has basically totally been wiped out. So we're left with 3x times the quantity x plus 1. If you look at problem 3, this is multiplying a rational expression by a polynomial, and by that just means that the second part of this thing that we're multiplying doesn't have a denominator. So not a big deal there. If it doesn't have a denominator, we'll just put it over 1, and then we'll go about our business just like we did on the last problem. So we put it over 1, then you can factor it. Notice 3m minus 6, they could factor a 3 out of that. And then m minus 2's could cancel out, and then they got their answer. So if you look at the got it 3, we look at got it 3 part A. So the second part here, we'll just put that over 1. And then I'm going to go ahead and start trying to see if there's anything I can do with that first fraction. So we can factor a 2 out of the numerator. That would be 2 times the quantity x minus 7. In the denominator, we can also actually factor out a 2, which would be 2 times the quantity 2x minus 3. And then this trinomial, I'm going to guess, is going to factor. Look in your denominator, and the only binomial we have in the denominator is 2x minus 3. So we're going to hope for an exciting problem here. I'm going to put a 2x minus 3 there and see what happens. So then our other binomial would have to be 3x. Signs have to be the same. Both have to be negative because it's a plus 6. So 3x minus 2. And then now the fun part, we get a cancel. So the 2's can cancel. 2x minus 3's can cancel. And then we'll just rewrite this so it's neater to look at. And then that should be our answer. If you have those switched around, if you would write it as quantity 3x minus 2 times the quantity x minus 7. That should be fine also. If you look at part B, is going to be a similar story. So the second part we can put over 1. So in that first denominator, you might notice that's a difference of squares, which we can factor as x plus 1 times x minus 1. In the numerator of that first fraction, we can try to factor that as well. We need x times x to get x squared. Everything's positive. The only option to get 1 would be 1 times 1, and that works. And if you want to, we don't have to worry about excluded values. If you want to go ahead and just cancel out the x plus 1 factors, you can. That will help you get an idea of what possibly might be in our second numerator. So this, we're going to try to factor. It's got to be a plus and a minus. I'm thinking there might be an x minus 1 here. And 1 times 3 is 3. So we got minus 1x plus 3x. That works. So the x minus 1s we can cancel. And that just leaves us x plus 1 times x plus 3. If you look at problem 4, they're talking now about dividing rational expressions. So just like we've done before with dividing fractions is keep, change, reciprocal. So if you look what they did on this problem, keep, change, reciprocal, and then it's exactly like what we were doing before. Once you keep, change, reciprocal, identical process to what we've done before. So if you look at the got it for part A, is dividing. So keep, change, reciprocal of the second fraction. And that's the big thing on these. Make sure you're not trying to reduce any factors before you change it to a multiplication problem. So now we can do some canceling. X plus y factors, one's in the numerator, one's in the denominator, those can cancel. And then also we have x's that can cancel. We have at this point cleared out our numerator, so we need to think about we need to have a numerator if we have a denominator. So we can just put a 1 there if you want. And so that would be 1 over y would be our final answer. If we look at part B, similar idea. I would just do keep, change, reciprocal before you start trying to do anything else, because you start trying to factor and stuff and then you might forget that you haven't done this yet, and then you might try and cancel things that can't be canceled, or think that you can't cancel anything potentially. So in the first fraction we can factor out a 4 in the numerator, so 4 times the quantity k plus 2. In the denominator we can factor out a 2. That would be 2 times the quantity 3k minus 5. And then these binomials are going to be the things I'm going to be watching for in the second fraction. Potentially, they could show up. So in the numerator, we've got a 3 we can factor out, and that would be 3 times the quantity 3k minus 5. 3k minus 5, that sounds familiar. Those can be canceled. If you want to wait and do all your canceling at the end, have a big canceling party, that's fine. But if you want to just go ahead and cancel those right now, you can do that as well. So in the denominator, we could factor k plus 2 times k plus 4. And k plus 2 we had, that we can cancel those out. And then if you look what's left in the numerator, we have 4 times 3. Oh, the numbers we can reduce as well. So The 2 and the 4, we can reduce both of those by 2. And then now in the numerator, we're left with 2 times 3, which is 6. In the denominator, we're left with 1 times k plus 4, which would just be k plus 4. Again, I would recommend the k plus 4 in parentheses so nobody tries to reduce the 6 and the 4 down. K plus 4, if you don't have another k plus 4, you can't reduce it. If you look at problem 5, is dividing a rational expression by a polynomial. So just like we did earlier, the only difference is we have something that doesn't have a fraction. You can put it over 1, and then dividing is going to be keep, change, reciprocal. So we're going to go ahead and jump down to the got it 5, and they want this quotient. So that second part we can put over 1, and then we can do, first of all, keep, change, reciprocal. The first denominator, we can't do anything with that. The first numerator, we might be able to factor. And I see that z minus 1, so I'm thinking that might be something we'll be working with here. Z minus 1 times z minus 1 maybe, and that works. So z minus 1s would cancel. And then it would just be z minus 1 over z squared plus 2. Put up your force fields, and that's our answer. One more thing to look at in this section is called a complex fraction. It's not as complex as it sounds. Complex fraction, basically it's just a different way of them writing the problem. So if they put it where it looks like a fraction over another fraction, you can just rewrite that. So they've got it here. They have AB over CD. That's the same as AB divided by CD. So probably would be good just rewriting that, and then keep, change, reciprocal just like we did previously. So you can see the example in your book. If you look at the got it 6, they're wanting us to simplify that. So we can just say this top part, this numerator, 1 over q plus 4 is being divided by 2q squared over 2q plus 8. So that's our first step, just rewriting it like that. And then at that point, just like we've been doing, we're going to say keep, change, reciprocal. And then we can try to do some factoring here. That second numerator, we can factor a 2 out. And then the q plus 4s you can cancel. Also the 2's you can reduce or cancel those out. And that would leave us with 1 over q squared.